Okay, here's your lesson on scientific notation. First question we need to ask ourselves is, what is scientific notation all about? Scientific notation is a shorter way of writing very large numbers or very small numbers using powers of 10. Number kind of should look like. So this may be the very first time you've ever dealt with scientific notation. Now, scientific notation answers, if I said, hey, write this number, write a number in scientific notation, it's going to look like this, which doesn't look like much of an answer, but that's it. So scientific notation, we're going to write it it's going to look like another math problem. But that's the point. That is what we call scientific notation. So scientific notation is, it's going to be basically a product. You're always going to have multiplication in here, always multiplication. And the first number, you have to put, or move, I should say, not put, but you're going to have to move the decimal point in such a way that it's got to be between 1 and 10. So what that means, it's got to be greater than 1 and less than 10. That's very important. 4.9 is between 1 and 10. You may also notice that 10 to the 7th power, that is called our power of 10. Now that's always, like I said, it's always going to look like this. The only thing that may be different, that will probably be different, is this 7, or is the power. The power is determined by how far that decimal point has moved. Has it moved, 2 places to the right, 3 places to the left, whatever. Wherever it is moved, that is what the decimal, or that's what the power of 10 is going to be. Let's go ahead and get into our first one. Okay, now what we have is a problem here that's in scientific notation already. I want to change it to standard notation. Standard notation just means write it as a number. That's what it means. What is it going to look like when you move all that stuff? It's going to be a number. That is the deal. So, let's look at what we have here. We have 6.1 times 10 to the 4th power. Now the very first step is to write it out as a decimal. Okay, I've already have that down. And I have not moved the decimal point. All I've done is just write out 6.1. Then, move the decimal to the right, equal to the power of 10. Now we're moving it to the right because of this rule right here, because it's a positive power. You will have negative powers as well, and I'll talk about what to do when we get to that. But we're moving it to the right because it's a positive power. So we're going to move it to the right. How many places? Well, that's the power of 4. So that's how far it's going to move to the right. So I'm going to move that decimal 1, 2, 3, 4. So I'm going to put 3 zeros on there, and the decimal moved right there. And there's your answer. 61,000. And if you want to write the decimal in there, fine. That's great. Put it in there. 61,000.0. Or if you don't want to write a decimal, that is fine too. There are your possible answers. Both of them are the same. Now here's an example of one where you have a negative power. Okay? So we have 8, and we need to change this again into standard notation. Standard notation just means write it as a number. 17 is standard notation. 1.3 is standard notation. So how would I write 8 as a decimal? Where is the decimal on 8? Well, if it's a whole number, the decimal is always right there. It's always after it. So I could write this very much like this, 8.0. And then this, let me just put these back under. This is a negative 6 power. So that means I'm going to move the decimal over 6 places to the left. That's what we're going to do. So we're going to move it over 6 places to the left. 1, 2, 3, 4, 5, and 6. So a lot of numbers here, and I'm going to put a 0 here, 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 and here. Okay? So there is our answer, basically. Okay, the decimal was there. It was there. Now it has moved there. How far did it move? It moved over 6 places. 1, 2, 3, 4, 5, 6. So it moved over 1, 2, 3, 4, 5, 6. Okay, so there's your answer. That would be 8 millions. So it's a pretty small number, 8 millions. Okay, here's another one. We want to change this one into scientific notation. We have not done that before. So what we want is first we want a number that is between 1 and 10. We want multiplication, and we want a power of 10 raised to some power. That's what we want. Okay, so we want a number between 1 and 10. Now, if I move the decimal there, that's not between 1 and 10. That's less than 1. If I move it here, that's 38. That's greater than 10. So I'm going to move it over 1, 2, 3. Okay, 3.8 is in between 1 and 10. 3.8 is greater than 1, less than 10. Times 10. Now the power depends on how far the decimal moved. So the decimal moved 3 places to the right, so I'm going to put a 3 there. But it's not going to be positive 3, it's going to be negative 3. Let me clean this up a little bit. So there's the answer. Now it's negative 3 because if we were to try to move it back, we would move it to the left. 1, 2, 3. So we would get smaller. So that's why it's negative 3. The hardest part about scientific notation is figuring out whether it's a positive exponent or a negative exponent. Just think, if it's going to be smaller, like a small decimal, it's going to be negative. And if it's bigger, positive, it's going to be like 4 million or 5,600,000 or something like that, or 56,000. So you're going to have a big number. So there's your answer. 3.8 times 10 to the negative third power. Pause the video at this point, try these out, see how you do, and then hit unpause to check your work. But really, try these out on your own. Don't just copy what I move it over to, which way? Left. I'm going to move that 2 to the left. So the decimal is going to move from here, 1, 2. So the decimal is now right there. So the answer is 25 thousandths. There you go. Now this one I'm going to move the decimal from here to here. How far is that? That looks like 4 places. So it's going to be 7.55 times 10 to the negative 4 power. Why is it negative? Because when we move it back, when we move the decimal, if we were starting out with 7.55, then it would get smaller. Here's a whole number times 10 to the third. So here's where the decimal is. 1, 2, 3 to the right. So I'm add a couple zeros, and that's 7,000. And there's the decimal, just for good measure. That's where it is, right there. This is 14,512,000. The decimal is right there to begin with, and we're going to move it all the way over here. So it's got a lot of places to move. How far is that? Well, that's 1, 2, 3, 4, 5, 6, 7. So there's what you got. 1.4512 times 10 to the 7th power. Notice I wrote all these numbers. I wrote all those numbers except for the zeros. And on this last one here, you had to figure out which one was bigger. So this one definitely looks bigger, right? I mean, 9.99, definitely bigger than 1.03. End of discussion, right? No, not at all. We still have to, figure out what these mean. So this is the power of 6, and this is the power of 3. So I'm going to change them first before I make that determination whether this one or this one, which either one is bigger than the other. So I'm going to compare these and figure out what they equal in standard form before I make that determination of which one is bigger. So 1.03 is going to look like this. 1, 2, 3, 4, 5, 6. So that's a big number. That is actually 1,030,000. Huge number. Okay, 9.99. I'm going to clear this slide. 9.99 is, we're going to move over the decimal 3 places. 1, 2, 3 is only going to be 9,990.0. So it's obvious which one's bigger. This one's bigger. And what's the kicker? The power of 10. This has a bigger power of 10, therefore it's bigger. This has a lower power of 10, so it's not going to be really even close to this. This is 3 more powers of 10 bigger. This is, 3 fewer. Okay, that does it, everybody. Make sure you guys write a reflection at the end of this. Try to figure out a little bit of a summary, and we'll be doing this tomorrow in class. Have a good night. See you tomorrow.